We are discussing about GATE 2006 ECE paper, and this question is related to electronics. An N-channel depletion MOSFET has following 2 points on its ID versus VGS curve. ID versus VGS curve means transconductance characteristics, that is transfer characteristics. And first point is VGS is equal to 0 at ID is equal to 12 milliamperes, and VGS is equal to minus 6 volts at ID is equal to 0 milliamperes. Which of the following Q points will be gives the highest transconductance gain for small signals? A. VGS of minus 6 volts, B. minus 3 volts, C. 0 volts, D. 3 volts. So the actual answer for this question is D. We'll see. First of all, we have to draw the transfer characteristics, that is nothing but ID versus VGS for a given VDS. These are transfer characteristics for the depletion mode MOSFET. For the depletion mode MOSFET, it is versus VGS and it is ID. And we know that one depletion mode MOSFET is nothing but where the permanent channel is going to be existing, so that even though you are giving VGS is equal to 0, there will be some current flows. Okay, that value is going to be treated as IDSS. If you apply more and more positive voltage, the current flowing through the depletion mode is going to be increases, and if you apply negative voltage for n-channel depletion MOSFET, the current flowing through it is reduces. So we can draw the characteristics like this. So the characteristics are going to be in this way. So this is where the drain current becomes 0, and this is the drain current at VGS is equal to 0 volts. This is the drain current increase as VGS is going to be increases. First we have to indicate the points given. At VGS is equal to 0, ID is 12 milliamperes. So this point is nothing but 12 milliamperes. So ID will be in milliamperes and this point is nothing but 12. Second point is ID is equal to 0. So where the ID becomes 0? At this point. So the VGS value is nothing but minus 6 volts. Now, which of the following Q points will give the highest transconductance gain for small signals? What are the points given? Minus 6 volts, minus 3 volts, this is the point, minus 3 volts, and this is 0 volts, this is plus 3 volts. Okay. So first of all we must understand what is meant by transconductance gain. Okay, transconductance gain is nothing but it is GM, indicated as GM is nothing but transconductance gain. For small signals it will be indicated as delta ID by delta VGS. Current by voltage is nothing but conductance. Transconductance is nothing but we are taking one parameter from the outside output side, one parameter from the input side. Delta ID by delta VGS. So for example, we are going with constant delta VGS. Delta VGS, change in VGS is going to be, for example, assume constant. By that time, whichever is going to be giving more delta ID, that will be giving the GM more. That is nothing but more transconductance you will get whenever delta ID is more for the given delta VGS. So we will assume the unit delta VGS as unit, and where this is delta VGS, and over this point this is delta VGS. The difference between x-axis between these 2 points is same. So this is, so these are the 2 points which is nothing but delta VGS. Again we are going for this one, this is delta VGS. So now if you observe delta VGS, that is on the x-axis, the difference between the 2 lines is going to be same, we are maintaining, that is nothing but delta VGS is constant. Now whatever you will see, the area between these 2 lines are going to be treated as delta ID. Change in ID is nothing but this one. From this characteristic for these points, which is going to be giving the largest ID possible? Is this plus 3 volts or not? So whenever VGS is equal to plus 3 volts, at that time these characteristics are going to be giving the more delta ID under the area, so that this will be giving the highest transconductance gain. Whenever VGS is equal to plus 3 volts, at that time that will be giving the highest transconductance gain. If the option may be included like this, something as E plus 5 volts. By that time this plus 5 volts will be the answer. Remember in that way. More positive voltage is nothing but more drain current for the depletion mode, so that will be giving the more drain current for the same VGS, for the same change in VGS. So transconductance is more. The right option for us is D. Thank you.